Hello students, in today's session of electromagnetic induction, for the very basics of motional EMF, motional electromotive force, will be cleared through illustrations along with comparison between Fleming's left hand rule and Fleming's right hand rule. Will also be discussed when it is applicable and when it is applicable. Please go through the complete video. Each and every point is very important for entrance point of view as well for the school exams. In another session, we have also discussed this, which you can review on CET. I will also like to say that the detailed solutions of these papers available on website cetdiscipline.com. प्लीज विजिट द साइट एंड हैव द सॉल्यूशन। इसी के साथ साथ मैं आपसे रिक्वेस्ट करूंगा कि अगर अभी तक आपने यूट्यूब चैनल CET सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर कलीग्स एंड फ्रेंड्स। नाउ लेट्स स्टार्ट विद द क्वेश्चंस एंड कॉन्सेप्ट्स। Concept regarding motional EMF. When a conductor moves in a magnetic field, then charges inside the conductor experience magnetic force given by F, a magnetic force, minus E V cross B. V cross B means when a charged particle enters in the magnetic field, it experiences a force. That force is given by this one. In this case, what assumption is very important? Assumption is that velocity of the charge inside the conductor. Velocity of the charge inside the conductor is same as that of the conductor, and the random motion of the charges inside the conductor is neglected as compared to the velocity of the conductor. Right? Due to this force, charges start moving in a particular direction. Charges moving like in a particular direction. Or we can say EMF is induced in the conductor. This EMF is known as a motional EMF. For a straight conductor, motional EMF is given as BLV. Right? If circuit is closed, current will be induced. Direction of current is given by Fleming's right hand rule. What is right hand rule? If we stretch the right hand in such a way that this is the thumb, this is middle finger, this is the forefinger. If this represents motion of conductor, this represents direction of magnetic field, then we have to find the direction of electric field. Then forefinger will be the direction of induced current. Direction of induced current. It is applicable generally in case of generators. Right? Fleming's left hand rule. Fleming's left hand rule is applicable when a charged particle enters in a uniform magnetic field. It experiences a magnetic force given by Fm equal to QV cross B. If we stretch the left hand in such a way that this is a thumb, this is a middle finger, this is the forefinger. If this represents the direction of positive charge, be careful. If it is negative, we have to change the direction of force. This represents the direction of magnetic field. Then this gives the direction of force. Right? This is only applicable in case of motors. Right? Now, straight conductor, motionally you have some mathematical expressions for that. E equal to BVL. In this case, E equal to half B omega L square. If rotating, means omega is the angular velocity. In this case, E equal to half B omega R square. These are the certain formulas. Now, start with the question. Question is, a conducting rod of length L slides at constant velocity V onto parallel conducting rails placed in a uniform and constant magnetic field B perpendicular to the plane of the rails into the page as shown in the figure. Resistance R is connected between the two ends of the rails. 5 parts are there to find out, identify the cause which produces change in magnetic flux, identify the direction of induced current in the loop, determine the EMF produced in the loop, compute the electric power dissipated in the resistor, calculate the magnetic power required to pull the rod at constant velocity. We will solve it one by one. Concept, applicable and solution. Concept, applicable and solution. In this case, it is given to you, cross means direction of magnetic field, is perpendicular to plane and into the page, and this means towards reader, that is into towards reader. These are the two important signs. Now identify the cause which produces change in magnetic flux. Now, as this rod is moving in this direction, as rod is moving towards right and change of area with magnetic flux is increasing. That is, crosses are increasing. Therefore, according to Lenz's law, B is to be produced to oppose the B is to be produced to oppose the increase in this. To oppose is to be produced. Means induced current will be produced anti-clockwise. Right? Next part. Next part is to find EMF induced. According to Faraday's second law. E equal to d phi by v dt equal to d by dt bl dx by dt. Act like this, dx by dt, that is bl v. Motional EMF. Next part is to find electric power dissipated in the resistor. Electrical power dissipated dissipated in the resistor. P electrical dissipated will be equal to I square R. According to Ohm's law, I equal to V upon R, that is EMF induced divided by the R, that is BLV upon R. This is the induced current. That will equal to B square L square V square upon R square into R. On simplification, this comes out to B square L square V square upon R. F electrical and the heat dissipated. And E mechanical power supplied. Mechanical power is required to pull the rod at constant velocity. Next part is mechanical power required to pull the rod at constant velocity. That is could be mechanical will be equal to F external into V. Here F external will be equal to F ampere, that is VI L. Therefore, P mechanical will be equal to VIL into V. Rearranging VVL into I. VVL is VVL into I. I is VVL upon R, that is B square V square R L square upon R, right? B square L square V square upon R. Now we see electrical power and mechanical power. Both are as P electrical equal to P mechanical. Means external power supplied, that is mechanical power supplied, is used or dissipated in the form of heat, in the resistor, right? Next question. Question is, two parallel rails with negligible resistance are 10 centimeter apart. This and this separation is 10 centimeter. They are connected by 5 ohm resistance. This is the 5 ohm resistance. The circuit also connected by two metal rods having resistance 10 ohm. This AB is the metal rod and EF is the metal rod. EF is the metal rod. Having resistance 10 ohm and 15 ohm. This is the 10 ohm, this is the 15 ohm. The rods are put away from the resistor at a constant speed of 4 meter per second towards left, and this is 2 meter towards right. A uniform magnetic field 0.01 Tesla is applied perpendicular to the plane of the rails. Your cross is given is into the paper. Which part is a higher potential, A or B? Also find the magnitude of EMF. Which part is higher, E or F? Also find the magnitude of EMF. Draw the equivalent electric circuit. Concept applicable in solution. In this case, one another rule is there, right hand rule. One is Fleming's right hand rule to find the direction of induced current. Another rule is to find the direction of current by right hand rule. Now in this case, this conductor AB is moving right with velocity of 4 meter. Velocity is given to you, direction of magnetic field is given to you. We have to find which is at higher potential, A or B. In this case, stretch your right hand, these fingers point towards the magnetic field and finger point toward the magnetic field, and this shows the direction of velocity v. Then what is right hand? This represents the direction of induced current or perpendicular upper palm of the right hand indicates higher potential, and lower palm, lower potential. In this case, these are the fingers like this. So upper arm is this is the lower. This is the upper, this is the lower. So B is at VB is greater than VA. Means if this is AB, then this is the direction of induced current will be like this. This is A, this is B, and EMF induced will be equal to BLV. 1 Tesla length is 10 centimeter apart. 10 centimeter apart. 10 to the power minus 2. 10 into 10 to the power minus 2 into velocity 4 meter per second. 4 meter per second. So this whatever the value of this is this much volt. Right? This is even say across AB. Similarly, for EF, it is moving towards the right. Right means finger point toward this is the upper arm. Means VE is greater than VF. V is greater than VF means direction of induced current will be like this. This is a higher potential, this is point E, this is point F. Now, similarly, we can find the E equal to BL. E is given, B is given, B is given, L is given, you can find the EMF induced. Equivalent circuit. Equivalent circuit will be, these are the two rails. One is and one is 5 ohm. So this is EAB, this is EF, this is 10 ohm, this is 10 ohm and 15 ohm. This is 10 ohm and this is 15 ohm. This is the equivalent circuit. This is the equivalent circuit of the given figure according to the requirement of the question. So one rule is Fleming's right hand rule, one is right hand stature. Right hand, this point towards the finger point towards the B, thumb point towards the direction of conductor. The upper end of the palm represents the positive. Higher potential, lower of the palm represents the lower potential. Right? Now, I would like to request, if you are new to my YouTube channel, SETI Shift Learn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.